In this video, we are going to learn to take a function like this and figure out what are the possible rational zeros according to the rational root theorem or the rational zero theorem. We will also factor this completely, and we will find the actual zeros. Now, according to the fundamental theorem of algebra, we should be able to look at the degree here and know how many actual zeros there will be. So there should be 3 zeros, because that's the degree, if we include imaginary zeros and irrational zeros with square roots in them, and if we count repeated zeros separately. So, first of all, let's find the possible rational zeros according to the rational root theorem. Now, we know the possible numerators are going to come from this constant term. The possible denominators are going to come from the leading coefficient. Now, this problem is a little extra easy because both of these numbers are the same. I kind of wish they had been different, but oh well, it's good for you because even if you do it backwards, you'll still be doing it right. So this 2 I'm going to put here, and this 2 I'm going to put here. Either way, the factors are 1 and 2. 1 and 2. Okay, so to find the possible rational zeros, I'm going to put these numerators over these denominators. I'll start with a denominator of 1. So I'll do 1 over 1 and 2 over 1. So 1 over 1 is 1, 2 over 1 is 2. All right, and then I will move on to a denominator of 2. So I'll do 1 over 2, and then 2 over 2 is 1 again. And I already have that. So these are the possible rational zeros, except for I'll put plus or minus in front of them. So it's going to be plus or minus 1, 2, and 1/2. Okay. Now, we need to write this in factored form. We need to factor this. It doesn't look like grouping is going to work. So we need to go ahead and find the zeros first, really. So we're allowed to use a calculator on this. So let's go ahead and type this function into our calculator. So I'm using a TI-30XS multi-view. Hit the table button. Already got something in there. All right, so let's see. 2x to the third power plus x squared. All right, 2x to the third power plus x squared minus 5x plus 2. So minus 5x plus 2. All right, I always start at negative 10 because it rarely goes beyond that. All right, I'm looking for 0 over here in the y column. That will give me the zeros of the function. So here I go. It's getting smaller, smaller, smaller. All right, so there's my first 0. There's one at negative 2. Okay, so I'm supposed to find all the zeros of the function. I've already found one. All right, so there's a 0 at negative 2. That means I have a factor of x plus 2. All right, these are basically opposites. To find more, I'm going to do synthetic division. Okay, so I'm going to use my 0 of negative 2 as I do my synthetic division. So here I go. So here's my negative 2 and the coefficients. So 2, 1, negative 5, and 2. Okay. So I bring down the 2. Just keep it. 2 times negative 2 is negative 4. Add them, I get negative 3. Negative 3 times negative 2 is positive 6. Add these, I get 1. 1 times negative 2 is negative 2. Add those, of course, I get 0. So to find the other zeros, I just need to factor this, assuming that it's factorable. So I'm going to go ahead and try to factor this right now. Well, actually, first let's put the variables back in. So this would be 2x squared minus 3x plus 1. So I can either factor this, or I could use the quadratic formula if I'm a big fan of the quadratic formula. But I will find factoring easier as long as it factors. So 2x squared can only be 2x and x. 1 can only be 1 times 1. All right? Now, inner plus outer equals middle. Inner, I've got 1x. Outer, I've got 2x. I'm trying to get negative 3 in the middle. So I would need both of these to be negative to add up to negative 3. If both of these are negative, that means both of these would be negative. And negative 1 times negative 1 does equal positive 1. So this is the correct factorization. Okay, so 2x minus 1, x minus 1. Okay, so there's my 2x minus 1, x minus 1. So now we have factored it completely. Now, the other zeros I get by setting these equal to 0. So for example, if I set 2x minus 1 equal to 0, adding 1 to both sides, I get 2x equals 1. Dividing both sides by 2, I get x equals 1/2. So this will be 1/2. And then setting this equal to 0, I get positive 1. So these are my zeros. Now remember, I was expecting to have 3 zeros because of the fundamental theorem of algebra. And in fact, here are the 3 zeros. So I know I am definitely finished. All right, for number 2, I'm given a function and I'm giving the graph. So again, we are supposed to write this in factored form. So I have to factor this, and I need to find all the zeros. Now, how many zeros should there be for this problem? There should be 4, because the degree is 4, so I'm looking for 4 zeros. Now, I see 2 zeros right away. I see a 0 here at 2, and I see a 0 here at negative 1. Okay, so 2 and negative 1 are zeros that I already see. So ultimately, when it says find the zeros, I'm going to have a 2 and I'm going to have a negative 1. And that's going to give me x minus 2, and that's going to give me, why am I putting a comma? No comma, we're just factoring. So this is multiplication. So I'm going to have x minus 2 times x plus 1. Okay, now there should be 4 zeros, so I know there are more coming. But you know what? For now, I'm just going to pick one of these. So I know that's coming, but I'm going to start off with the 2. And it shouldn't matter whether you start with the negative 1 or the 2. But I'm going to start with the 2, and I'm going to do my synthetic division and see what happens. Okay, so I'm going to put my 2 right here. That's my first 0. And my coefficients are 1, negative 1, 7, negative 9, and negative 18. Well, it's a little crooked. Okay, so here I go. If I bring down this 1, 1 times 2 is 2. Add these, I get 1. 1 times 2 is 2. Add these, I get 9. That looks like a G now. Whatever. 9 times 2 is 18. Add these, I get 9. 9 times 2 is 18. Add those, I get 0. Okay, so looking at this pattern, 1 divided by 1 is 1, 9 divided by 9 is also 1. I could do grouping right now if I wanted to. That would look like this, because I have x to the 3rd power plus x squared plus 9x plus 9. I could do grouping by taking out the x squared. That would leave x squared plus 1. I could take out the 9, and that would leave 9 plus 1. Okay? x plus 1 is now a GCF, so I could bring out the x plus 1 out front, and that would leave behind x squared plus 9. X squared plus 9 does not factor. So these are my factors right now, x plus 1 times x squared plus 9. So I could go ahead and write that down, x plus 1 times x squared plus 9. Then I could get my zeros by setting these equal to 0. Okay, so that's one way I could do it by grouping. Now I'm going to go back and do it another way, and you can just decide which way is easier for you. Alright, so many students would prefer to just use the other 0 that we found. So -1 is another 0. So if you want to use another 0, what you do is you just go ahead and write it down next to the bottom line. And then you just draw another line and put your remainder box under the last number there. So you just do your synthetic again with the next 0. So if I bring down this 1, 1 times -1 is -1. Add these up, you get 0. 0 times -1 is 0. Add that up, I have 9. 9 times -1 is -9, and there I get 0. Okay, so at this point I'm using another 0 of -1, so I'm going to go ahead and write that down, and that's going to correspond with a factor of x plus 1, so I will go ahead and write that down as well. Okay, now, so we knew that from the beginning. But to find the other two zeros, I will go ahead and factor this. So if I put the variables back in here, this is x squared, ignore that, plus 9. So there's my x squared plus 9. But then this does not factor, so I will just go ahead and write it down. So x squared plus 9. If this had been minus 9, I would go x plus 3 times x minus 3. But because it is addition, you cannot factor it any further than this. And again, so now if I want to get the zeros, I will set this equal to 0 and solve. Okay, so this part you have to do regardless of which method you use. So if I set this equal to 0, I'm subtracting 9 from both sides, so now I have x squared equals -9. And then now I'm going to take the square root of both sides. Whenever you take the square root of both sides of an equation, the solution can be positive or negative. Okay, so I'm going to have x equals plus or minus. When you have a negative under radical, that becomes I. So that's like having this sort of. Most of you would just do this in your head. But the square root of 9 is 3. So I'm going to have 3i. So you can either write plus or minus 3i, or some students like to write this separately. By writing 3i and then negative 3i. So these are the 4 zeros that we were looking for. Okay, and this is factored form. So that's it. This is the complete answer for problem number 2. All right, now problem number 3 is practically the same thing as problem number 2. Okay, so I'm going to take this function and I'm going to factor it, and I'm going to write all the zeros. But I'm going to use the graph. So let's see, we've got a bunch of zeros here. Well, I've got 3 that I see really clearly. All right, I've got this one here is 1. This one looks like it might be 1/2, but I don't want to guess at that. This one is -1, and this one is -3. Okay, so we got 1, -1, and -3 are the zeros. So I really could write all those down right now. 1, -1, -3. Okay, that would give me factors of x minus 1 from this, x plus 1 from this, and x plus 3 from this. Okay, but that leaves that third one, the fourth one, I'm sorry, that's in the middle. So I'm going to use synthetic division to find out what's going on. Okay, so, all right, so I've got this 2, 5, negative 5. So I'm just going to start with my 0 of 1 and do my synthetic division. So here's my 1, and I've got 2, 5, negative 5, another negative 5, and 3. Okay, that's all I need. So here I go. All right, so if I bring this 2 down, 2 times 1 is 2. Together that makes 7. 7 times 1 is 7. Add those up, I get 2. 2 times 1 is 2. Add those up, I get negative 3. Negative 3 times 1 is negative 3. Add those up, I get 0. All right, this time grouping is not happening. I don't see any pattern. So I'm just going to go ahead and use the next 0 on my list. So far I've done the 1, which would give me the x minus 1. Now I'm going to use the negative 1, which would give me the x plus 1. Okay, so I'm going to do the negative 1 now. All right, so if I do the negative 1, I'm going to bring that down. 2 times negative 1 is negative 2. Add those up, I get 5. 5 times negative 1 is negative 5. Add those up, I get negative 3. Negative 3 times negative 1 is positive 3, so there I get 0. Okay, so I could factor this to get my other two zeros. Okay, one of them is going to turn out to be x plus 3. So I could even use that to help me factor this. So I've got 2x squared plus 5x minus 3. Okay, and I'm trying to factor this. So I know I'm going to have 2x and x. Okay, and look, I already know I'm going to have x plus 3. So this must be just plain x plus 3. And it's going to be 3 times 1. So, so inner, I've got 1x. Outer, I've got 6x. So I need this to be a negative 1 to make 5. So there you go, 2x minus 1 times x plus 3. Okay, so there's my x plus 3 that I already had. All right, and now I've got the 2x minus 1. All right, if I set 2x minus 1, if I set 2x minus 1 equal to 0, adding 1 to both sides gives me 2x equals 1. Dividing both sides by 2 gives me x equals 1/2, which is kind of what I thought. So there it is. These are the 4 zeros, and these are the 4 factors.